Hi everyone, my name is Juhao. I'm very happy here to share my last papers, which are accepted in attribute unit communications. The title of the paper is Stuck in Intelligent Metasurfaces for Wireless Communications, Application and Challenges. And I will introduce this paper in the 5 sections. The first in the background. As we all know, with the evolution of the wireless communications, which lead to some new challenges have to be solved, and this comes up some new technologies. For example, the massive MIMO, the hybrid MIMO, the reconfigurable holographic surfaces, and this technology can handle the new challenges from the evolution of the wireless communication, but it all have some limitations. For example, the massive MIMO have the high power consumptions. The hybrid MIMO have the limited flexibility and complex radio frequency design. The RHS holographic surfaces just a single layer structures, which limits have the limits processing abilities. So we introduced this kind of new technology which called the stacked intelligent metasurfaces, which we call the SIM following. The SIM has the multi-layer structures, have the wave demand processing abilities, and it can reconfigure the EM behavior. Also, it has the low energy consumptions. And then the SIM hardware types. First, we have to introduce some benefits of the SIM. It have the parallel computing, because the parallel processing of the EM waves is realized automatically through the multi-layer metasurfaces, and with the multi-layer and the wave EM waves go through the SIM. The computing is automatically performed, so the computing is performed in the light speed, so it has a very low delays. The next is the energy efficiency. Some work measurements in 28 GBit band show that the energy consumption per bit processed lower than conventional solutions. And we introduced 4 SIM hardware in these papers. The first is the HES, which as H means the static. It's a fixed structures manipulates EM waves without requiring additional energy for computation. And this paper is shown its hardware prototype. The second is the Pro HP, which means programmable passive. It's reconfigurable, and once we configure, it operates without additional energy consumptions. And these papers use it in SX systems. And the third is the programmable active, which is HA. It's also is reconfigurable, but each method is integrated with an amplifier. It has a promise to achieve nonlinear active functions and it makes the SIM to do some nonlinear interference. And in this paper, it shows the hardware prototype in the papers. The third section is the application of SIM. And the first, we introduce wave demand analog beamforming. We choose here with the SIM join into the transmitters, which makes the transmitter to do the SIM-based transmitters. It comes some changes compared to conventional transmitters. For example, it can remove the digital decoding because the signal processing is all performed by the SIM, the stacked intelligent metasurfaces, and the digital to analog converters is transformed from the high resolution to low resolution, and also the radio frequency chains transmit from the large number to the small number. There's 2 changes, and it's a benefit for the hardware cost and energy consumption of the overall systems. Also, the wireless channels is also changed from the low dimensional to high dimensional because the a large aperture of the SIM. And also, because the larger approach of the same of the metasurfaces, the really distance is expanded. It brings some changes to the near field region from the small to the large. And the right side, we show the simulation result. We take the near field systems use the same base transmitter to do the wave demand beam frequency in the near field communication systems. And we can see that the multi-layer architectures provide performance gains. And with sufficient layers, for example, the 8 layers, SIM achieved zero force level beamforming performance. The second application is which takes the SIM as a semantic encoders in this task-oriented semantic communication systems. And in this systems, the SIM takes the two tasks. The first is a source encoder. We make the image to the transmission pattern of the first layer, and then the following layer do the semantic encoder to do the layer processing to the uniform beams. And the last we classify just made by the receiver antennas. We use the receiver antenna energy distributions to directly recognize the category of the transmitted image. And the right side also shows in this semantic communication systems simulation results. And we can see that SIM can transform the information bearing signal into their corresponding beams, and the system achieve an overall accuracy of 84%. The fourth part of the presentation is the opportunities and the challenges. Because of SIM has the capability of the wave demand signal processing, it have the low delay and the low energy consumptions. So it can use in these areas, for example, the high mobile communications, SAC, and still field networks. Also, it can use in security communications and in some energy in some energy consumptions is involving important scenarios as a non-terrestrial networks and also the relay networks. Also, SIM technology face some key challenges, and here we introduce some solutions. The first is the practical hardware imperfections, the efficient SIM configurations, because the SIM has multiple metasurfaces, and each metasurface has a very large number of the meta-atoms. So it has a high dimensional parameter space. So it also brings the performance analysis is also a challenge. The last is the SIM deployment. How many meta-atoms are we need, and how many meta-atoms on each meta-surface is the optimal number. It also the challenges and the detailed solutions we showed in these papers. The last is the conclusion. In these papers, we presented a comprehensive overview of the SIM technologies, covering its advantages, hardware architectures, and we explored the key applications in wave demand beamforming and semantic encoding, demonstrating the capability of the multi-layer structure. And the last, we identify emerging research opportunities in high mobile communication, cell-free communication, and so on. And then we discuss some key challenges and corresponding solutions. And that's all my presentation. Thank you.